Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. This is going to be an interesting video because I had to switch all my OBS screens around because I need two monitors for programming this FPGA, and I needed a monitor for my OBS to look at to see what's going on. So I have it on a smaller monitor. I hope everything is showing up here. So, FPGA. So this is a Mojo V3 clone board. It's down here on the bottom. There's an HDMI shield here, and then there is the I/O shield here. It is not plugged in right now because we haven't programmed anything. It does do something with it not plugged in, with it not programmed. And I did mess around with it and do one thing, so I'll plug it in. It's hard to see. Let me turn this off here. There you go. And this one. Alright, hold on. There we go. Gotta make it a little darker. So, there you go. You can see that, and then there's one light down there. So I'm going to lighten this up so we can see what's going on here. So that way you can see the board a little bit better. There is numbers, but we're not going to be doing anything with the numbers. We're going to be doing some other stuff and try to get this programmed up. So we're basically going to be looking at the lights down here. Basically, the blue lights. So, the Mojo V3 board is phased out. They're not even selling it anymore. Their new board is the inaccurate AU. It's way more expensive than I can afford, so I got this clone of a Mojo V3 and a couple shields for it. But they still have tutorials on creating a project in the Mojo IDE, which is this section over here. And I'm basically going to go through this first tutorial of creating a project. This was a nightmare. It took me 8 hours yesterday to get this working because you need to download this ISE software from Xilinx, and then I had licensing issues, but I got it all figured out into the day, and now we are ready for our first project. For your very first project, we are simply going to wire up the reset button to one of the LEDs on the board. We will make it so that the LED will turn on when you push a button, and when you push the button. Go ahead and double click the left side where it says Mojo. Top V under the hierarchy panel, the file should open and see the following code, and that's what we see. So we see that. Let me explain which part of each code does. We have the port declarations. This is the declaration port. It tells the signals we're going in and out of the module. Remember, we are designing circuits, not writing code. So it's good to think of each module as a block that has some inputs and generates some outputs. For now, we are only interested in the RST_N input and the LED's input. So this is the input RSTN, and then the output 0 to 7. Now this bracket thing here, from what I understand, this is LED 7 down to LED 0. So that's how that works. You may have noticed the line, this is not a single output, it's actually 8. You can create an array of wires or registers by using those brackets. What 7:0 actually means is that the LED will be an array of 8 wires and will have an index from 7 down to 0. It is possible to do 8 to 1 or 0 to 7, but unless you have very good reason for doing it, you should stick to the convention, mixing what you used as a base index in the order can create major headaches. Okay, declare wire, that is the... So this is declaring a new wire, calling RST and assigning it a value. The common convention is to name a single name signal that are active low, meaning 0. meaning a 0 is active by appending the underscore end at the end of their name. Following the convention, R underscore N is active low, but we want an active high signal to make RST an active high version of RSN. We can just invert the RSN with the squiggly operator. It's the not operator, so that's what it shows right here. That's what this is right there. So it's not RSN. So in this case, we are declaring a 1-bit wire. However, you can declare an array of wires, sometimes also called n-bit wire, where the n is the width of the array with the following line. So wire something 9 array. Okay. In this case, we should now have a 10-bit wire called array. Notice here I did not assign it a value. Okay, assigning a value. There are many times where you want to assign a value to a wire that is already declared somewhere else. In this case, you can use the assign keyword. Okay, so this is, they're assigning 1 bit, and they're assigning it to high impedance. And here they're assigning 4 bits to high impedance. And then here's the LEDs, they're assigning 8 bits as all zeros. So constant looks something like 8 HD. In these 3 cases, you can tell how many bits wide each constant is by the first number. The first one is 8 bits, the second 5, and the third is 4. This is important because you want to use the constraints widths to match the signal you're assigning to it. The second part of the constant is the base for a number, which means H is the number in hex, and D means decimal, and B means binary. The rest of the constants is an actual value. You may now look at the sign statements, and what the value is Z, that's the high impedance, and X is an unknown variable. Okay, so now let's look at the last line. This is what we care about right now. We're just assigning the LEDs to be all 0. That means all the LEDs will be off. What fun is that? Let's make a small modification to that line. So let's go over here, and we're going to change we're going to go to LED. Looks like bracket 6 colon bracket equals 7. We want those to be a 0. Okay, so now we want ASSIG assign LED open a bracket 7 bracket equals RST semicolon. Okay, so we're assigning the 7 bits of LED 0, so you can use the brackets in some notation as subpart of your way. Reset connects LED 7 to reset. Okay, so now I need to build the project. So let me check the syntax. Okay, column 30, no variable alternatives at input. I didn't put the 0 there. 0, so let's check the syntax. No errors detected, so let's build the project. This can take a little bit, and then this will tell me if I have any errors down here. So, how long has this video been? Oh, it's only been about 9 minutes for our first program here. I am learning this. This is my second day with this. I spent all day yesterday getting the software installed, and I turned on one LED down here, and then I on this I tried to get these LEDs to turn on, but I messed up somehow, and then I stopped trying, and I'm like, hey, you guys probably want to see me mess up, so I am going to go through these tutorials on the Mojo here and see what is going on here. So it's waiting to finish. Okay, it's finished building project. Let me plug in my Mojo here. Let's plug this in. Okay, so we got that plugged in and on camera. And now I'm going to program it. It's loading it. Okay, now let's check this out here. So if I press this button, boom, when I press the button, the LED lights up. So whenever I press the button, the LED lights up. So I wrote a piece of code. Now, you're saying to yourself, ooh, you lit up an LED with an FPGA. You could have used a $12 Arduino board. That is true. I could have used a $12 Arduino board, but I wanted to learn this FPGA to do more complicated things. I have an idea of using it as a CPU and an 8-bit computer, and I also have an idea of using it for my shift register game, the code crack game I'm making, to simplify the logic to where I build it with all logic gates. So I'm mainly going to be using this to build logic gates, to use combinational logic. I'm not going to be driving a lot of microcontroller type of stuff. It's mostly going to be combinational logic that ends up working my code crack game, or running through a sequence of logic operations, or a parallel version of logic operations to give me an output, and then I can input a variable and it runs a different set of logic operations. And that's what I am looking to do with this project. So we did it. We made the LED light pushing the button. I am going to end it here, and we'll check out tutorial 2 in the next video. So this was, I thought this was going to be like an hour long, but it wasn't. Check me out on my, okay, check me out on social media. You can also, okay, OBS is, so check me out on social media. That's gonna do it, guys. Oh, there's the Patreon page. So thank you guys, and have a fantastic day.